I want to talk to you about autoscaling, specifically Kubernetes autoscaling, and more specifically, like node autoscaling. I have long time been a proponent that said autoscaling was kind of a waste of time, a waste of engineers' time. It wasn't something that people should be doing for a couple reasons. And those reasons mainly are, one, no one ever knows what they're trying to autoscale to. Like it's always this moving target because the environment is dynamic. It's not something that's like, we should go to this and how do we get there? It always ebbs and flows during different times of the year, all these things. And like a person tuning these requests would never really made that much sense. And the second reason is because people either did it for cost savings or they did it for scaling. And in both those cases, they could only do it for so much cost savings and so much scaling. You actually can't auto scale to infinity in the cloud like a lot of people think. It's not how it works. Who the heck is this guy to tell me about autoscaling? I'm Justin, and in 2017, I wrote a book called Cloud Native Infrastructure. It's an old book now, don't read it. It doesn't go into a lot of details on this stuff. After some time, I was working at Disney on Disney Plus when Disney Plus launched. It was one of the largest consumer launches in internet history at the time. And we did almost zero autoscaling on the day that we got 0 to 10 million signups in 24 hours. That's all pre-scaled. This isn't like something that we're just like, just let auto scaling handle it. It's not how this works. After that, I was working on EKS. I worked at Amazon on EKS as a service. I did a variety of things such as writing the best practices on how to scale large Kubernetes clusters. I also did the best practices on how to save money on large clusters. I also helped launch the Karpenter autoscaler. This is something that Amazon had to build because of problems that Amazon had with their infrastructure. You see, Kubernetes had this cluster autoscaler that existed for a very long time, and it relied on node groups or autoscaling groups in AWS terms. But the problem was, Amazon's autoscaling groups were really bad, and they were bad in two specific ways. The first one was you couldn't pick what zone you were putting an instance in. So when the autoscaler said, go give me a node, it just put it out there, the autoscaler +1, and the autoscaler picked a random AZ to put it in. And that normally would be okay, except for the second thing, that Amazon EBS volumes are zonal locked. They do not work at a region, they work on a per zone. So if you have a workload on a node that requires an EBS volume, and then the ASG starts to spin up a new node in a different AZ, it can't schedule there. The workload still can't mount that EBS volume because it doesn't exist in the zone. This is a problem that folks like GCP don't have. GCP has autoscaling groups that you can fine tune and say which zone it's going to land in. And they also have volumes that allow them to span an entire region. So this problem just didn't exist for other cloud providers. It existed for Amazon. And so they had to solve the problem. The other thing Amazon did was they thought, how else can we take advantage of an autoscaler? What other benefits does AWS have that maybe other cloud providers don't have? And the main benefit they had was just a plethora of instance types. They have hundreds and hundreds of instance types. As a matter of fact, I wrote a whole blog post years ago about just explaining what the families are, how they exist, and then you can like how to pick the right one. But this was all like really hard for engineers to like, oh, well, this one has these performance characteristics and these are this way and costs and all these things. There was too much complexity to keep in your head. And so people were building these auto scaling groups with the standard Kubernetes autoscaler that had dozens and dozens of autoscaling groups. And then you had to fine tune like which one should scale when, how should they scale, all this stuff. And so they started mixing autoscaling groups with like different instance types. And the EKS team asked the ASG team like, hey, can we get like fine grain on which zone should an instance come up in? And we talked to the EBS team, can we get regional EBS volumes? And in both cases, these were two hard engineering problems. So the EKS team built a new autoscaler called Karpenter. I have an old video that has been watched tens of thousands of times by people just understanding what's the difference between the cluster autoscaler and Karpenter. How does it work? And the main thing that it does is it brings what autoscaling groups give you in Amazon and it pulls them in as native Kubernetes resources. It turns out other providers had this problem too. Azure was one of the first other clouds that wanted to use Karpenter and not the cluster autoscaler. Again, if you're in GCP, use the Kubernetes cluster autoscaler. It works great in the GCP environments. Other clouds don't have some of the benefits that GCP has. You don't need to use Karpenter everywhere. It's not going to be end all solution for all cloud providers to say, well, just use Karpenter. This is the right solution. No, Karpenter does a very specific thing to solve very specific problems in an Amazon first way. It's now been donated into the CNCF. It's part of the Node Autoscaling group. It's managed by multiple clouds. It has evolved since then, but the reason it existed was infrastructure dependencies that couldn't work well inside of a Kubernetes environment. Karpenter had this idea of not only could we find out prices and the exact right fit for your instant or for your pod that you were trying to schedule, it also could do something called reconciliation, where it would do holistic rescaling of the cluster at a global scale, because the cluster autoscaler would only look at nodes that drop below thresholds. It wouldn't necessarily try to rebalance to say, oh, these should be spot and these should be different instance types. Karpenter could reduce the spend by taking a holistic approach of scaling the cluster. And this was a huge benefit for a lot of the EKS customers we had at the time, because they did not realize just how much waste happened over time. I have another short video where I spun up arbitrary workloads at different sizes for weeks at a time. I would just let it scale up and down, up and down, up and down, because it was a more realistic approach to what it looked like in a cluster over time that was getting these scaling events. And this was just using Karpenter to scale up and then using Karpenter to actually reconcile holistically the cluster. And it was a huge savings of just how much resources in the cluster were being wasted just because of little scaling up and down over time without holistically looking at how should we renegotiate where these workloads run and what instances do they actually need. By planning out these types of workloads, need these types of node pool, by moving the scheduling concern towards the application. The applications know best what type of instances they can run on. And so moving that concern to the application is the best approach. It is the absolute best way to make sure that you can keep your cost low while also keeping your performance and your reliability high, because that's the real trade-off here. When we're auto-scaling, no one really considers the risk involved of what if I can't get that instance type? What if my init scripts fail? If you're relying on auto-scaling to give you the performance and reliability characteristics, you're gonna have a bad day. At some point, it's going to bite you, and some repo is not going to be available. Some container can't pull, all of these things. So auto-scaling isn't an end-all be-all for saving money. It's if you're up and down auto-scaling by 10%, you're not really saving that much money. You should just make a better plan for what you actually need. If you're auto-scaling up and down 10% to get better performance, again, make a better plan, shift some of that stuff to the developers, to the application side of things to say, actually, we can get better performance on some of these instance types, and you should pin that to your application to make sure you always get some guarantee of performance. All of this dynamic infrastructure ends up being a lot of wasted time for engineers who spend the time trying to fix anomalies. And that's the thing that I always kind of didn't like about auto-scaling in general. And I always tell people, don't waste your time on auto-scaling. Just pin the amount of instances in your cluster and then just leave it there and make sure you can run that successfully first. People always jump to the cloud and say, I got to auto-scale and I'm going to save money. And it's like, that's not where you're saving any money. That's just more work for you. And that doesn't even go into the whole, like, how do I auto scale my workloads? The HPAs and the VPAs and all of these other dynamic features that are looking at metrics of requests. Those are all other things that just add more complexity to the environment. And at the end of the day, humans shouldn't be in that loop. This video is sponsored by Cast AI. They asked me to look at their platform and give them honest feedback about what I thought about it. And I've never looked at Cast AI in the past. I've known about it for quite a while, but it just wasn't something on my radar because it wasn't something that I was using. Working at Amazon, we weren't using Cast AI. Working at Disney, we were actually using all ECS when I was there. We were using traditional metrics with CloudWatch and auto-scaling groups for that auto-scaling. And since then, I do a lot of on-prem hardware stuff. You're not auto-scaling your hardware. You'd be sending an email to get a PO to like rack and stack something new. Cast AI hasn't seen this video. I'm giving my honest opinion after doing my own research. They didn't give me any prompts on like, oh, go look at this thing and try this one out or anything. I looked through their documentation. I watched the videos and talks they had about it. And then I wanted to make my own informed opinion about what I think about their platform. And while looking through all of their documentation, I found two things that I was particularly interested in. One was they had an integration with Karpenter where they said, okay, Karpenter works with Cast AI. You can have a Karpenter autoscaler, and Cast AI can complement Karpenter in a way that works better at a business. And that sounds really interesting to me because, again, Karpenter is a building block. It's not the whole picture of what you might need. And the other thing I wanted to try that they had was live migrations of workloads that were stateful applications that go from one node to another. That's been one of those holy grail things of Kubernetes that people have been chasing for quite a while, and mostly around like VM migrations, but really just around like anything stateful. Now, I didn't actually get a chance to try the live migration for myself. This was something that I really wanted to see where they were hooking into Containerd, what shims they were putting in. And the thing that stopped me from doing it was the fact that it required specific instance types in cloud providers, and it didn't work in an on-prem environment. I'm going to trust that it works in their demos. They've done plenty of demos about it. They have plenty of documentation about it. I'm just going to trust them that the thing technically works. I was more interested in how they solve that problem because it's not a generic thing that Kubernetes can do. I also know it requires a specific version of Amazon Linux, Amazon Linux 2023 to be specific. It's not something that I was really interested in diving that deep into. I just kind of wanted to know what the technology was underneath, but it was more something that I was interested in at a bare metal environments, and it doesn't work there. But we can dive into the general Cast AI autoscaling just to see how it works in an environment where you might have Karpenter running. And so the very first thing that I was trying to do was actually run Cast AI with auto mode, the EKS auto mode, to see, does it actually work with managed Karpenter? Amazon runs Karpenter for you for autoscaling, and they also are responsible for the nodes. The nodes are running inside of Amazon environments. You don't necessarily see them, but you have access to the workloads. It's similar to GKE autopilots, but it's just like the Amazon flavor of that thing. And unfortunately, no, Cast AI doesn't work with auto mode. So again, if you're all in on Amazon, you're using auto mode, that is a different cluster type that you can't use for like a generic autoscaler. You don't have access to Karpenter. You don't have access to the instances. So I abandoned that and I wanted to instead let's try generic Karpenter, where I'm actually going to run an EKS cluster where I manage Karpenter and see how it works. Cast AI also has an integration for obviously other cloud providers. So we're going to run a GKE cluster, see how that works. Because again, GKE is automatically going to give me the cluster autoscaler. Again, that's managed by Google, but I do get some access to how the nodes are going to run. I'm not running an autopilot cluster. I'm running a standard GKE cluster that just so happens to have some of these features. And then the third thing I wanted to run was actually on my home lab. Let's add some nodes from my home lab because Cast AI does work with other Kubernetes clusters. So I'm running this on my home lab on top of Talos Linux, and we're just going to run it, the agent, and see what it reports and just see how this kind of consumes information and what it can and can't do inside of a more static generic Kubernetes cluster. I don't have an autoscaler. I don't have Karpenter. It's just 4 nodes running in my house. And then for all of these clusters, I had these scripts that let me create a bunch of deployments that request various amounts of CPU and memory. And so it's not like one type that I scale 1,000 times. It's a mix of different workloads just to give it a little bit of complexity around you need to actually do a little bit of math to figure out what's going to fit and what's not. So once you get the Cast agent installed, these are the workloads that it runs in the cluster. There's a bunch of them. There's some agents that are like looking at your API server. It works essentially the same as all the other node autoscalers, where it looks for pods that are unschedulable, and then it looks at what type of resources they're requesting, and then it tries to match that. It says, okay, you need this much CPU, you need this much memory. So when I deployed it to my on-prem cluster, which I just called Cast, it gave me this cluster score. I don't know necessarily how it calculates this, but it's mostly around this like cost efficiency. And I find that funny because cost efficiency is like, how much are you using the CPU and memory that you're paying for? And this is something that matters in a dynamically scaling environment where you can replace the nodes at will. In this case, in an on-prem environment, I already paid for these nodes 5 years ago. Like this, I'm not paying any more money except for minor electricity costs. And so obviously I was not consuming a lot of the resources. These are bare metal nodes. I did like that Cast AI like gave me a cost based on it. It prompted me for like, hey, how much does this cost you to run? And then it says, hey, this cluster costs you $1,000 a month to run. I'm like, oh, that actually feels kind of nice. Like, right, if I was running this in a cloud environment, this would be a lot more money to actually try to run this. But then after deploying my workloads and clicking around, I'm just trying to see what is it that we can actually do in this environment that is statically provisioned. And really it's just about seeing, okay, if you actually had some way to optimize this by removing nodes, you could save some money, but obviously we're not going to be able to do that because again, it's not something that we can do in an on-prem cluster. It was fun scaling up the workloads and then seeing like it change my score on saying like, oh, you're using a lot more of your CPU now. So your score is up, you're using 80%. Once I did that, I actually had one of the nodes start crashing on me, which was really fun to try to troubleshoot. And I get this like jagged graph here that was showing off, hey, this is a problem. You're losing resources and adding resources over and over again as that machine was boot looping. But let's look at the Karpenter cluster. The Karpenter cluster is really where Cast AI's like ideal fit, right? It's going to be in these sorts of environments that are running in a cloud environment. They do have some way to auto scale. Cast AI has like multiple ways to do this. You can do all your auto scaling through Cast AI. What I found, at least with these sample workloads that I was running, is Karpenter did a really good job at initially setting up the auto scaling and just giving me instance types. Cast AI has a separate consolidation setting here that'll let you do this like over some time. Karpenter has that same sort of setting where it does the node rebalancing, it tries to empty nodes, and it's all like native Kubernetes resources. So you're doing this all from Kubernetes YAML. If you're doing this with GitOps, if you're trying to do this in a more programmatic way, it's probably the way that more people are going to look at this. But I liked some of the features that Cast AI was adding to this as far as like, how aggressive do you want to be, right? These are things that are kind of added on top of what Karpenter is going to do to try to save even more money. But I still want to reiterate, if you're doing this to save money, the long-term strategy is to have a plan, is to plan out what workloads you're going to run, figure out how much they're going to cost, what type of instances they should run on, and either get reserved instances or architect your application so it can run cleanly on spot instances. When I was looking at the live migration settings, this was again where I kind of figured out, okay, there's limitations here. This isn't a live migrate for anything. This requires these AMI families. It requires a label on the nodes. It requires certain instance types. And it also requires the migration to be within a zone because EBS volumes can't cross that zone. So this isn't for those sorts of scenarios that I initially thought it might be. Cost efficiency. This is something that other folks like KubeCost and other companies are trying to provide this sort of information at a high level for business deciders. Like, okay, how much is this actually running? How much is this namespace cost to run, because we can associate that directly with like some revenue, right? Some application costs this amount of money. Is it worth it? And when is it going to be worth it, or when does it make up the money? Interesting thing here on the Karpenter node list is you can see Cast AI changed everything to a spot instance. Those two nodes that are the on-demand, those are the ones managed by AWS as part of the cluster itself. Those are like the static node group that gets provisioned. That's where I'm deploying Karpenter, right? I have two Karpenter instances. They're both requesting different nodes, right? Different host names, and everything else is workloads. Those all run on these spot instances. It was interesting to me just because how aggressive Cast AI was at, you should be using Spot. Like, please put Spot in here. Don't rely on on-demand instances, which is true if you're trying to save money. Cast AI is adding a bunch of stuff for like spot interruption and pre-spot interruption, these things that are like, how do we make sure that Spot can be a little more stable for these workloads? I found that interesting because Karpenter, again, vanilla Karpenter is only going to use what Amazon provides. It's going to use the 2-minute timer for a spot interruption. It's going to allow you to set some mix on spot instance versus on demand, but it's not actually going to go as far as what Cast AI is going to do to give you schedules on how these things work and let you scale down the cluster at a certain time. Those are all additional features that Cast AI is bringing. That's a more complete solution for like the complexity of a business. Looking at the GKE cluster, this is, I would say, as traditional as a Kubernetes cluster as you can get. I think GKE is still, in my opinion, the gold standard for running Kubernetes in a cloud environments. It is the closest thing you can get for the abstracts of Kubernetes matching the underlying infrastructure. And this is something that is really critical in how you manage a cluster, because the further those worldviews diverge, the harder it is to make them work together, right? If again, like bare metal Kubernetes is kind of hard because Kubernetes always assumes that it can just replace a node. And it's just like, actually, I can request another node from an API. It's like on bare metal, that's not how this works, right? We have in-place upgrades for a reason because we bought the hardware and it exists for 5 years. GKE and GCP in general, right? Like these are concepts that Google was really good at. These are things, that's why it came out of kind of Google, is the mental models worked better together. And in the way GCP functions and the way it separates things out by projects and just how it manages node groups. And all of those things just worked in a way that was kind of Kubernetes native before other things were. And when you're trying to move some of those worldviews into other cloud providers that had their own opinions first, the worldviews don't match up as well. The things you would expect just work. Like there's rebalancer and being able to see, okay, well, how much money would you actually save me? And the fact that Cast AI does it in a similar way across all of the cloud providers makes that just smoother, right? When you're working with a Karpenter cluster versus a cluster autoscaler cluster, things work differently, and you need to make sure that operationally you have one place that you can kind of check that things are working the way you want them to. Cast AI being optimized for cost savings and autoscaling, obviously they can focus really tightly on that view of the infrastructure. And it makes it easy if you're looking for that information, if you are someone that is part of your FinOps teams or whatever you're doing, to be able to say like, I just need this view. It's going to be a better view than something like the EKS console, right? The EKS console is a very generic interface, and it doesn't work by default. EKS never changed. This was a problem back when I was working there. I love that it's still a problem today, where, depending on how you created this, you may not have access to view the console. Really stupid stuff. When Cast AI told me that they had a Karpenter integration, I made the assumption that Cast AI was going to create node groups inside of the Kubernetes cluster, and it was going to influence Karpenter by like changing weights on node groups and things like that. What actually ended up happening was Cast AI was taking over some of the consolidation and creating its own nodes. Karpenter, again, it's out of the loop if it's not trying to place a pod or do specific consolidation. If there's nothing to consolidate, it's just going to sit there and not really do anything. Cast AI, because it was doing this consolidation and it was already looking at spot instances and replacing that stuff, it was doing it for me. I did like that the things like a rebalance plan that was showing up in the Cast AI UI actually is a Kubernetes resource where I could get this information. etcd is not a good database for generic information, and we just overload it with annotations, which I found like not a good interface. But at the end of the day, I could query this stuff natively in Kubernetes, and being able to pull that in from Kubernetes directly instead of requiring me to authenticate and go to some external API is a big win. That's something that I do like having, and just the fact that I can have a plan and see the plan being carried out natively in Kubernetes is better than what you might get with Karpenter, it's not making resources for plans. And you can see that in the Cast AI documentation, what resources are Karpenter's and which ones are coming from Cast AI. And this is their controller, which is like their integration with Karpenter. So it's just giving you these sorts of like plans and migrations and those sorts of things, but everything else is pretty standard EC2 instance type scaling. I'll also say that while I was running these clusters, I was doing some AI investigation just to see what does it think is going on here. I did have some trouble initially getting the cluster up and running. Again, EKS clusters have always been this problem in the worlds of not only do they take 20 minutes to provision, but they don't always work correctly the first time. And so by like mixing CloudFormation with Kubernetes YAML and trying to put this stuff together, it just gets to be kind of a mess. The limit for the default node group in Karpenter was 100 cores, and I couldn't scale over 100 cores. So as I was adding workloads to the cluster, Karpenter stopped adding nodes to it. It says, oh, we're not going to scale up here. And Cast AI also didn't add nodes to it. And the AI was like, actually, you're never going to get nodes here. These are all stuck. And so I like started cleaning them up, and I don't know, the memory of the AI agent was like, you're going to be, this is never going to happen. And I had to like eventually tell it like, actually, no, I deleted all the workloads. Like, where's it at? It's like, oh yeah, you're absolutely right. And just kind of sucks sometimes. So overall, has my opinion of autoscaling changed? No, with a couple caveats. One is autoscaling is still not for large bursting events. It's not for recovery. Auto-scaling is for small incremental changes that are within a margin of error for your plan. You should be making a plan based on what you think you're going to be running, at what scale you're going to be running it. And as the customers scale up or scale down in some cases, you should be going according to that plan. And the auto-scaling is just making up some of those margins. It's not doing these big, we can auto-scale the worlds, because even if the nodes can auto-scale, even if the compute says I can fit the pod, your other supporting services won't. Your load balancers need to be warmed. Your container registries may not have enough bandwidth to pull those images. All of that stuff is like, you should plan those out. You should think critically about how much compute do we need? What is our budget for it? How do I make those things fit? And then plan accordingly. Auto-scaling is to make up the gaps of either we don't know how to plan certain things or we didn't plan this in advance. And those are things that you can scale things down and save a bunch of money by saying, let's just get rid of the waste, or take into consideration things that are hard to know because Amazon has hundreds of instance types and you can't know all of them. Every reinvent, there's 10 more and you're like, I don't know, should I use those? Let the automation tools figure that side of it out. And the thing that Cast AI is going to be good at is for those FinOps teams, those platform teams that have some budgetary constraints and they say, actually, I need to hit this goal. What are the knobs that I can tune to get there? And what are the trade-offs that I'm giving up to get to that point? Usually you're giving up some reliability or some performance or just some certainty. Spot instances are great until you can't get them. You need to plan for those sorts of things. You can't just rely on Spot always being available for all of your workloads at any scale. And if you're trying to do this yourself, if you're adding Karpenters to the cluster, if you're adding Kubecosts to the cluster, if you're trying to build up all these free tools and put them all together and make them one cohesive view, I mean, Cast AI exists and you can pay just money to like buy the thing and say, actually, here you go. I'm going to save a bunch of time and then we're going to see if this works for us. And that actually is a valuable use of your time to not have to manage this stuff. It's great that these tools exist in a holistic approach that work across cluster and cloud provider boundaries.